I wanted to help you with the sample Chapter 2, Chapter 3 exam, just so that you can verify that you have the right answers on there. I'm grabbing a pencil, and here we go. So here they're asking us to complete the ordered pair. They're telling us they don't know what the x value is when the y value is -5. So I'm going to put my work right here. Y equals -5, and then we have 2x minus y equals 4. Y is -5. When I resolve that double negative, I have 2x plus 5 equals 4. And I'm going to take away 5, excuse me, from both sides. You see where the 1 came in, right? And I'm going to get 2x equals -1, and I'm going to divide by 2, and that's going to tell us what x is, -1/2. Then here they're saying that the x value is 0, so I'm going to put that in the equation. 2 times 0 minus y equals 4, and that's good because that's gone. So we get -y equals 4, and all we have to do is divide by -1, and now we know what y is. Y is -4. And then we finished out those ordered pairs. They're asking us what quadrant does this point 9, -4 lie, and you could kind of plot it if you liked. Over 9 down 4 would be in that quadrant, right? And this is quadrant 1. This is quadrant 2. This is quadrant 3. And this one over here is quadrant 4. So it lies in quadrant 4. Then they're asking, is the point 2, 7 a solution to this equation? Answer yes or no. And so what you're going to be doing is plugging in x is 2 and y is 7. So this is going to be 7 equals 3 times 2 minus 3. So that's 6 minus 3. Well, that's not 7, right? And so the answer is no. 6 minus 3 is 3, and 7 doesn't equal 3. So if they had been equal, then we would have said yes. Here they're asking us to graph by plotting the 3 ordered pairs. So you have to make sure that you do have 3 ordered pairs. So since this is in standard form, my favorite thing is to choose x is 0 and y is 0. Because it's in standard form, x and y on the same side of the equation. So when x is 0, this gives me -2 for y. And when y is 0, that gives me -3 for x. And then maybe perhaps I will pick, and you can pick anything you want. Maybe I will pick x is +3. Just because I wanted to pick x, I just changed the sign on that, thinking maybe it will make a whole number. So 2 times 3 plus 3y, you can pick anything. It doesn't have to be a whole number, it can be a fraction. So here I get 6 plus 3y equals -6. Taking away 6 from both sides, I get 3y equals -12. So I'm going to divide by 3, and I get y equals -4. And then I'm going to plot these. So over 0 down 2, over -3, up 0, over 3, 1, 2, 3, down 1, 2, 3, 4. If they don't look like they're on the same straight line, then that means that you have made a mistake. Go find it and fix it. And so remember that if you, on your test, don't have a way of printing, then you need to have grid paper. And so here I printed, so I didn't have to use the grid paper. And make sure that you draw your line long all the way through the points to the side of the graph and put arrows on it. Okay, when it's in slope-intercept form, this form, solve for y, then I like to pick, if you have a fraction, the multiples of that fraction. So the multiples of 3 are 0 is a multiple of 3. That's always my favorite point. And 3 is a multiple of 3, and perhaps -3. And so I'm going to be putting that in here, 0. So 2/3 times 0, well, that's -4, right? Because 0 minus 4. And then when you put a 3 in here, right, imagine with me, 2/3 times 3 minus 4. So many people tell me that they are not good with adding and subtracting fractions. and I get that. And so multiplying fractions, I guess, is what I got going on here. So you can use your calculator, right? And I'm okay with that. And I say try it by hand and try it with your calculator so that you get where you're more proficient with the other. So I was saying that was -2, and you can see that it is. And you can put the negative in here, and I don't have to redo it. So this is -6. I had the other one, I had 0 in, so I'm going to back it up and put in 0. So now I've done it with my hand and my calculator. So I'm going to plot these points. It asks me to come up with those 3 ordered pairs. So if you wanted to come up with those 3 ordered pairs and then use the slope and the y-intercept to graph it, you could, or if you want to plot these points, you can, but it asked you for those, so you need to make sure that you do give those or you won't get full credit. 1, 2, 3, 4, over 0, down 4, over 3, 1, 2, 3, down 2, 1, 2, over -3, 1, 2, 3, down -6, and there is my 3 points on the line. 3 points on the line, so I'm drawing in, and I'm making my arrows on either end. Notice I made a really long line. Okay, so this line was going downhill, right? Slope's negative. This line's going uphill, the slope's positive. Just saying that because we have it here just so we can review that, because that's sometimes something they ask me, right? Okay, so here they're asking us to graph the line, and they're saying to come up with 3 ordered pairs. Because it's in slope-intercept form, I like to choose 0, and then this would be -5. I'm going to be picking convenient points. I'm going to pick 1, and then when I put in 1, 6 take away 5 is 1, so 1, 1. 2 is 12, take away 5 is 7. So I try to keep points that stayed on my grid, right? Like I was noticing that -1 would be -11, and that would go right off my grid. So, and then I'd have to rescale. And so as long as you can keep 2 points on the grid, that's good. -5, down -5, 1, 2, 3, 4, 5, over 1, up 1, over 2, up 7. Pretty steep line right there. Okay, so we did a good job on that. This one's in standard form. So since it's in standard form, I like to choose the zeros. So when I choose x is 0, then I'm going to see that y is -4 over 5. And when I choose, and where that is when you plot it, is over 0, down 4/5 is right there, right? Not quite to -1. And then I would choose this to be 0, and I would get 4/3. Now 4/3 is 1 1/3, right? It's equivalent to. So that's over 1 and a little wee bit more, up 0. Okay, so those points were fractions, and so I even choose them if they're fractions. If you want to try to come up with a point that's not a fraction, sometimes it's harder to come up with something that's not a fraction, but sometimes you can too. I don't know. Let's try 5 just to see, because I was thinking if I put 5 in here, then maybe this, no, it's not going to be that won't, because of the 4 over there. I was trying to come up with something that would be good. 6, and if I had this be 6, then I'd have to take away 6. How about if I make this -2, then this will be, so just trying to fill around for getting something that would be two whole numbers. If you're saying, well, I don't like to do that, do I have to get whole numbers? And the answer is no. If it's too much trouble, if it's easy to get whole numbers, you should. And this one here, it took a little thinking, but then I was able to come up with a whole number. Coincidentally, -2, -2. So over -2, down -2, and you can see that that is looking like it's on that line there. And so we'll plot that in there. And I can kind of see that, if it's, if I kind of adjust it, it's perfect. And if you're like not sure, like you're feeling like, did I have to adjust it too much? Because we did estimate both that point and that point when we plotted it. Well, you can get a fourth point under those circumstances. And so I kind of figured out that -2 made something good. Let's see here if I can think what would make something good here. So this is -5, so I'm going to subtract 5. If I add 5, if this is 1, right, that would be good, actually, if y is 1. So this would be 3x minus 5 times 1 equals 4. And so this is 3x minus 5. See how that equals 4? And when I add 5 to the other side, I get 9, which is divisible by 3. So that's what's kind of tricky, is you have to kind of start thinking, you know, what would I let my y be so that it would be divisible when I added it to that other thing? Get your number sense kind of going, I tell you. So 3. So 3, 1. So over 3, 1, 2, 3, up 1. And now I feel more comfortable because, boy, that's on my line, you know. They're now all on my line. That was almost like half a point. When I made it a whole point, it looked better. Okay, so we did a lovely job on it, and it was like I was unsure if I was perfect, so I got another point. And I tried to, I paid close attention, trying to get a whole number if I can. Here it says, tell the slope and graph it. So this is y equals -3. This is a horizontal line. I have memorized that. If it doesn't have x in it, it's horizontal. And all lines that are horizontal have slope 0. So no reasoning out on that, just recognizing. And then how you graph it is you come here on the y-axis to -3, and you draw a horizontal line through it. This one over here is vertical, and so I notice it's vertical. I know that all vertical lines have slope undefined. If you put, that's a D, undefined, handwriting. If you put no slope, I'll also take that. That's what your book says. Often, they also say undefined. And it's a vertical line. It's 1, 2, 3, 4. So you go on the x-axis to 4, and you draw a vertical line. Okay, and then that's all they were asking there. Here they're asking me for the slope through the points, and then for me to say what kind of line it is. So the slope, remember this is the slope formula. And I got to be careful here because I was told that on one of these, when I was finding the slope, that I substituted on accident in the wrong value. And that definitely can happen, so you guys want to be really careful as well. -7 and 3 and -2 and -2. So here I get -10, and you know that's 0, right? Because that's -2 plus 2 is 0. So this is undefined. So the slope is undefined, and if it's undefined, then that means it is a vertical line. So if the slope is undefined, it's a vertical line. So we'll try that here. So our slope, I got the formula written up there, so I'm not going to write the formula again. I'm just going to fill in the blanks here. So this is x1, y1, x2, y2. So this is 6 take away 4, and -4 take away 3. So the numerator is 2 and the denominator is -7, and your book would write that as -2/7. And so either way, so that's not 0, so it's not horizontal. That's not undefined, so it's not vertical. So that means it's slanted. So that's all that's left. So we did great on that. So here they asked me for the slope and the x-intercept and the y-intercept. And I can see it's going downhill. So that tells me that the slope is negative. So if I don't get that the slope is negative when I do my rise over my run, then I want to rethink what I've got going. So I'm going to run over here this distance, right, in this direction, 1. And so I can line up with that. So the run is 1 equals 1. And then I'm going to rise, but I'm going in the negative direction. And that distance, right, this distance is 1, this distance is 3. So it's negative 3. So the slope is negative 3. So you want to reduce it, and negative 3 over 1 reduces to negative 3. So the slope is negative 3. The x-intercept is negative 1. And of course you can write that as negative 1 comma 0. And the y-intercept is negative 3, and of course you can write that as 0, negative 3. So we did a lovely job on that. And that's all they asked us to do there. They could have asked us to find the equation of this, and I did ask you that on the lab. And so think about how would you do that, right? And so it's certainly possible. I know I have those where I ask you for the equation coming ahead. Here they're asking you to find the slope, the x-intercept, and the y-intercept. And the slope, because this is in slope-intercept form, y equals mx plus b is slope-intercept form, and that tells people for free the slope. It's 2. And it also tells them the y-intercept for free. It's negative 9. So to find the x-intercept is a little more work on this form. And how you find the x-intercept, no matter what your equation looks like, is you let y equals 0 and solve for x. And so this will look like 0 equals 2x minus 9. So all I have to do to solve for x would be to add 9 to both sides. So it's not impossible, it's just not as easy as the y-intercept, right, or the slope. So I get 9 equals 2x, and then I'm going to divide by 2. So I get 9 halves for the x-intercept. And so if you're saying, well, I thought how you found the y-intercept, so just to compare, right, 2 ideas on finding the y-intercept. So this is a compare, right, versus, I'm going to try this. I thought that to find the y-intercept that you let x equals 0 and solve for y. And you do. Y equals 2 times x minus 9, right? You let it be 0. And so now I don't have any work to do to solve for y. I get negative 9. So that's the reason that it's that, because when x is 0, then it's negative 9. And so it is a shortcut when people tell me, oh, it's just that. It's a shortcut of this. Okay, so they're asking me for the slope, the x-intercept, and the y-intercept. This one's in standard form. And so that is, the x-intercept is actually a little bit easier in standard form than it is in this form. How you find the x-intercept, that was an x, but it started off with a naught. How you find the x-intercept is exactly the way that you found it here, right? You let y equal 0. So when we do that, we're going to have minus 2x plus 3 times 0 equals 6. That goes away, and we get minus 2x equals 6. So we get that x equals negative 3. And you're fine to write that in shortcut notation or to write that as negative 3, 0. And I was saying that here, and then I didn't write it. This is 9 halves 0. And this is 0, negative 9. Either way, shortcut notation or in ordered pair notation. The y-intercept, well, it's pretty easy right here too. Remember, you let x be 0. Negative 2 times 0 plus 3y equals 6. And so this is gone. So we get 3y equals 6. So that means y is 2. And that's the y-intercept. Okay, so that's doing it from standard form. You can't find the slope in standard form. What you have to do if you want to find the slope is you have to rearrange this equation from standard form, S-T-A-N-D-A-R-D, right, standard form. This is a standard form, into slope intercept form, which means solve for y. And then the slope will be really easy. So all you have to do to solve for y is add 2x. So we're rearranging this equation. We're not, it's going to still be the same equation, just in a little bit different order. So this is 2x plus 6. Then I'm going to divide by 3, all three terms. And I get y equals 2/3 x plus 2. In this form, the y-intercept is free. There it is. You notice it's not different than when I found it in standard form. So you can find the y-intercept in either form. It doesn't matter. And the slope is 2/3. Okay, but I can only find the slope from slope-intercept form. And the x-intercept is actually easier found from standard form. So if they've given me the equation in standard form, I just want to leave it alone and find it. The x-intercept is definitely easier from standard form, but the y-intercept doesn't matter. It's easy from both forms. And the slope can only be found from slope-intercept form. So there you have it on that. Here they're asking me, and it's like, and my font got kind of fishy, and I apologize about that. I have put this, I think, as a PDF, so it's not gotten fishy. The reason is that there's some issue down at school where I wasn't able to print down at school, so I had to take it someplace else, and the fonts are different. And anyway, so when that happened, it kind of like this is looking funny, but I'm pretty sure that the slope, this is the slope right here. It's solved for y is 3/2. And the y-intercept, well, it's 5, right? It's right here. The x-intercept, though, I'm going to have to work a little bit for it. The x-intercept is when you have to let y equal 0. So I'm going to have to solve this. My choice on whether or not I just multiply by 2 to get rid of the fraction. And so 0 times 2 equals, and then 2 times 3/2 x, and then plus 2 times 5. I normally would do that in my head. I'm going to write this so I don't start writing into my box there. But I wanted you to know I multiplied every piece by 2, right? So I got 0 here. I got 3x here. I got 10 here. And I'm going to write this over here just because I'm going to run into that and I'm out of room and I've written too big and all of my stories, right? So taking away 10, I think I'm still kind of neat compared to some of the I mean, I think I'm writing my work, I'm hoping, neat anyway. And so trying to keep my work as neat as possible because I want you to be able to follow what I had. So I kind of drew my line because I was having my answer kind of come into here. There we have that. Okay, so we did a lovely job on that. And then here they're asking me to find the equation of this line. In order to find the equation of the line, you have to know what type of line is it. Is it horizontal? Is it vertical? Or is it slanted? And you can clearly look at it and see that it's slanted. If it's slanted, then you need to know its slope. And we usually use its slope to say that it's slanted. I use the visual to say that it was slanted. But I do want to say the slope. And so, so I need to know the slope. And the slope is the rise over the run. And so I'm going to go, Mr. Heater said always try to go from left to right. And so I'm going to do that. So I'm going to be going over here to 3, right? So this is going to go, this distance here, this distance right here that I'm going to be running over here is the distance 3 when I went from 0 to 3. So that's my run is 3. And now I'm going down, so that's negative, and I'm going down 5. Do you guys agree? Counting 1, 2, 3, 4, 5, or you can say I'm at a height of 5, and now I'm at a height of 0. So negative 5. So that's my slope, negative 5/3. And then when it's slanted, then our next thought is, for a slanted line, is do you know B, which is the y-intercept, question mark. Well, yeah, I do. It's 0, 5, B is 5, right? That's what the y-intercept is 5. And so I smile to myself because it's easy to find the equation of the line. This is the equation builder, and all you have to do is plug in what you know m is and what you know b is. The equation of the line has y in it. The equation of the line has x in it. And so I'm just plugging in the number for m, negative 5/3 x, and I'm plugging in the number for b, plus 5. So there's the equation of the line. And that's all they asked me to find, right, was the equation of the line. But I had to find the slope in order to find the equation of the line. Here they're asking me to find the equation of the line. And again, I ask myself, anytime someone asks me to find the equation of the line, is it horizontal, is it vertical, or is it slanted? And I usually use the slope to tell that. And I can see here the slope is negative 5. That's what they're saying that the slope is. So that tells everyone it's slanted, because horizontal lines have slope 0. Negative 5 is not 0. And vertical lines have slope undefined, and undefined is not negative 5, so it's slanted. And so then, because it's slanted, I ask myself, do I know B, the y-intercept, right? Is that something that's known to me? Known? Question mark. And I go right here to that point, and I'm asking that point, are you the y-intercept? Are you the special point? And the answer is no. The y-intercept has in its value right here, it has 0 for x. That has 4. And so when I plot this, in order to stay on the y-axis, your x value has to be 0. Otherwise, you immediately move off of that axis. When you go over 4, 1, 2, 3, 4, down 2, it's the over 4 that got me off of the axis, right? And so, do I know the y-intercept? No. So there is another equation builder for slanted lines, and it's this: y minus y1 equals m times x minus x1. And I know I've said it before, there's other ways of doing it besides using this equation builder. This is just what our book shows. And I think that we already have enough, so I did not show you the other method. Although lots of students have showed me the other method because they learned it somewhere else. And guess what? I'm cool with you using the other method. It doesn't matter to me at all. And so this method is plug in and chug and plug is what it is. So equation of the line has y in it, minus y1, and y1 is negative 2. Resolve double negative I'm going to be doing. Negative 5 x minus 4. So the first thing is to resolve the double negative, and this does get really cookbook because it's always the same. It doesn't always have double negative, but it always has distribute. So that's the next step, is distribute. And then I'm going to, and it always has add or subtract. So I'm going to be subtracting here too. So the equation of the line is y equals negative 5x minus 18. It's plus 18 though. And so there we have the equation of the line. So you did a lovely job on that. Then they are asking me, find the equation of the line that passes through these 2 points. So I ask myself, anytime that I'm asked to find the equation of the line, is it slanted, or is it horizontal, or is it vertical, right? One of those 3. I want to know what type it is. I usually use the slope to know what type it is. And I notice, well, they didn't tell me the slope. And so, well, I'll find the slope then, and then I'll be able to type it, right? So this is the slope formula. Those subscripts stand for the y value of 0.2, the y value of 0.1. So this is x1 is the x value of 0.1, y1, x2, y2. And I can't help but notice, you guys can't help but notice too, that in the denominator I'm having 3 take away 3, right? The x's are the same, so that when I subtract them, I get a denominator that's 0. And so my numerator is not 0. My numerator is 7 take away negative 4, which is 11, right? And so whatever number I had up there, this is still undefined. So if it's undefined, the slope, then that means it's vertical. And its equation builder, now that I know that it's vertical, the equation builder, and I don't normally write this out, but you know, I'm writing it out so that you'll know what I'm thinking. So you can go way faster when you're just doing it as opposed to trying to write out every one of your thoughts. X equals a number. Well, what is X? X is 3. So the equation builder is X equals a number, and this point agrees. And if they didn't agree, it wouldn't have been vertical. So we did a lovely job on that. Problem 18, find the equation of a horizontal line that passes through this point. So they're saying it's horizontal, and I know that the equation builder, EQ builder, right, for a horizontal line is y equals a number, and our number for y is 2. Y is 2. So there's the equation of the line. Find the equation of the line that passes through these 2 points. So again, what kind is it? Is it slanted? Is it vertical? Is it horizontal? Right? Question mark. Which one is it? It's one of the 3. So I won't say question mark like is it one of them, but which one is it? I want to know. And my slope is, and so x1, y1, x2, y2. So my slope is y2, -7, take away y1, which is 2, divided by 2, take away 3. So in the numerator, I have -9. In the denominator, I have -1. And that's 9, right? Negative divided by a negative is a positive. So 9 is the slope. So now I know it's slanted. This is not the, so the next thing I'm asking myself is y-intercept. Do I know it? Because if I do, I'm like hot diggity dog, right? And that's not the y-intercept. That's not the y-intercept. Remember, the y-intercept has x is 0 and then some value. So I don't know that. So I'm going to have to use the point slope equation builder. So my equation builder is called point slope, is what it's called. That's when you know any point and the slope. So it looks like this: y minus y1 equals m times x minus x1. And then you have to solve it for y. So we're going to be having here y minus, and I'm going to use here, this point is the point I'm going to use. If you use that point, and I did it in a previous video, you'll get the same answer. Not with this exact numbers, but with a different one, and you will get the same answer. If you want to try it, you can. If you don't, then you have made a boo-boo, or I have made a boo-boo. No double negative resolve. And so I'm multiplying away here, and I'm going to add 2. I did the distributive property, and I think that's going to be 25. Y equals negative, not negative, 9x minus 25. I think the negative was coming from the 25. And there we have that. There's our equation of our line. Then they're asking me to graph this. So I have to graph the boundary. And the boundary happens at equals, and it's going to be a solid line. Solid line. Okay, so 6x minus 9y equals 18. My choice, I like to use convenient points. You use something different. I'm already putting in x is 0. Because that's the convenient point I'm going to use. So 9 is negative, y is -2. I'm going to put in 0 here, and then x is 3. That was pretty convenient. They were nice. They weren't fractions like that other one I did. And I'm just going to go with 2 points. It didn't say I had to have 3. And so the minimum number is 2, unless it says you have to have 3, and then you need to have 3. And the reason I'm going with less points than I normally would is because I want to eat my soup. And okay, so solid line. And then I'm going to do a test point. So this is the first step. The second step is my test point, TP test point. And I see that 0, 0 is available, not on the line. So 6 times 0 minus 9 times 0 is less than or equal to 18. 0 is less than or equal to 18. That's true. So that means that 0, 0 is in the solution region. And I'm going to quickly shade above that line. So the line is part of the solution and all the shading above is part of the solution. We did a good job on that. And now we're moving into chapter 3, right? So those were all chapter 2 problems. This is chapter 3 problems. They asked me to solve by graphing. And so I feel like I've done this very problem before. Did I put this on the lab, this one? Or am I wrong? If this is 0, then this is -1. So 0, 3 over 0, up 3, 1, 2, 3. -1, 0. Yeah, I think I'm misremembering. So there's that line drawn. It's certainly a similar problem, but I thought it was exactly the same problem. That happens with me sometimes, is that I think something's so good. And I think that this line is the same, and I think that line is not the same as what I'm thinking. So over 0 up 5, over 0 up 5, that's at 3, 4, 5, and then 1, 6 is here. So I can kind of see, you know, where is that thing crossing? There, maybe I'll go over and get 2, 7 and put that, right? If this is 2 and 7. So over 2, 7. Zero. Oh, there it is right there. It's not crossing at a nice point. So I'm thinking, what have I done wrong? It's not crossing at a nice point. And I've already drawn that other line in there. And I know that it should be crossing at a nice point. And I carried it down wrong is what I did. So these points here are not right because I did it on a different equation. And I told you that I had memory of doing this one. And then I was like, oh, those weren't the points I had. So I'm going to put the first one in here, the second one in here, and draw it. Okay, and then I'm going to be more careful because I changed it. So if this is 0, 0, then that's really -3. And if this is 0, then this is really -1. So actually that point was okay, but it was this one that wasn't right. So over negative down 3, right? 0, 1, 2, 3. And then this point was right. And then put those together. And I told you guys that it needed to cross out a whole number. That one wasn't crossing out a whole number, so that kind of told me that maybe I did something wrong, and I got lucky and looked over there, and I did. This one's not exactly crossing out a whole number, but it does look like it's crossing at -2, +3. So I'm going to put in here -2, +3, and see if it solves this equation. 3 times -2 plus 3, right, equals -3. -6 plus 3 equals -3. So this is, it did solve that one, right? Check mark. Well, does it solve this one? -2, 3. So we're going to plug it in there. 3 equals -2 plus 5. That is 3 equals 3. And so this was -3 equals -3. So this is check mark. And this is our solution. It's the same value in both lists, and so our solution here is -2, 3. On your test, you have to have both lines graphed correctly. So now I have both lines graphed correctly. And so a lot of times people just tell me the solution because they used a different method. And they say, well, I didn't want to use graphing, even though it said to use graphing. And so I used a different method. And I'll tell you that in the rubric, I have points for this line, I have points for this line graphed correctly, and I have points for the solution. And so you want to make sure that you have graphed both lines correctly. So even if you find the solution using whatever method that you want, and then you go back and you make sure, I'm going to make sure that my dot looks like it's on the point that I said it was on there. And then you go back and make sure that you graph those lines correctly. Okay. So graphing these lines correctly, you can use whatever method that you want. Me, in particular, like to use convenient points. You can do whatever you like. So when you're choosing, you get to choose. So this is going to be -2, and 0 is going to be 1. So the reason I like to use convenient points is because it's easier and for me, and it's something that we learn first. And so a lot of people have practiced it. So maybe it's not only easier where we learned slope-intercept later. And so sometimes people haven't practiced it as much. And so I get more buy-in on convenient points. So now I'm thinking about picking some more convenient points here. And so I'm thinking about picking 0, 1. And if you like to use the slope and the y-intercept, you certainly can. And I'm going to pick 1, and that's 3. So 0, 1, over 0, up 1, over 1, up 3, 1, 2, 3. So those lines certainly do look parallel with one another. And so particularly right through here, and I could pick more points to get it looking a little better down here. I think that you can see that I didn't go right through the center of that dot. And so I'm pretty sure they are parallel with one another. Now, when they're parallel, that means there is no solution, right? Now, if I wanted to check to make sure that they were parallel to one another because I was worried that my graph was just a little tilted, right? You know, I can't help myself but feel like I want to draw that one again. You're like, oh, please don't be that way. But, I'm like, won't be able to help it, right? And so now that I've gone through there a little bit, now they're looking very parallel, right? If I wanted to make sure, I would solve this one for y. And then it would be in slope-intercept form. And parallel lines, remember, have the same slope. So you could quickly do that just if you were wanting to check that they were parallel with one another, dividing by -1, all of these, right? And so you can see that the slope, that's -1 there, you can see that the slope is 2 as well. So the slope is 2 here and the slope is 2 here, but they're not the same line. And so that means that they're parallel and they have no solution. And so anyway, we did a lovely job on that. Okay, so this is 23, and it said that I can use whatever substitution or elimination. It's set up to use elimination, so I think I will eliminate x. So I'll eliminate x. So when I eliminate x, I'm going to be multiplying this equation by -5. So every piece, -5 makes -10x, minus 60y, and -10. And one arithmetic error, that's what people tell me. All I did was make one arithmetic error. It seems like you should be able to make one arithmetic error and still get the right answer. And that's not the case. So remember, I was eliminating x, so I get 10x here. I get 6y, and equals -26. And when I add these equations together, I get -54y equals -36. And when I divide by -54, I'm going to know what y is. And it's not particularly a wonderful value, but it's not the worst value in the world either. It's a fraction. Fractions happen. It's a pretty nice fraction. It's 2/3, right? So I want to find y. I have choices on how to do it. So this is my choice. I can choose choice, right? Choice 1, if you will, is you just put in y into equation 1. So this is 2x plus 12 times y, which is 2/3, equals 2. So that's my choice. And this choice is substitution. Right? And I used elimination here. And then I choose to substitute in. And that would be a great choice. This actually comes out nice. And so since this comes out nice, I'm not as unhappy about the choice as I was. 12 times 2/3 is 8, I think. And so let's make sure that it is 12 times 2/3 is 8, just like I thought. So that's wonderful. So 2x plus 8 equals 2, taking away 8. So I get 2x equals -6. So I'm going to divide by 2, and I'm going to get -3. And we're like, hot diggity dog. Now I know x and I know y. And my solution then is -3 2/3. People always ask me, do I have to write it as an ordered pair? And the answer is yes, you do. You need to write it as an ordered pair. The solution looks like an ordered pair. So you should write it as an ordered pair. If you don't, then you will not get full credit on it. And so you want to make sure that you do. Now, you could have also had the choice. So this was my choice. I could have used elimination again, but I could have eliminated y instead. And so come over here and done that. And so whatever choice you make, you're going to get x is -3, whatever you do. Now, you should always check. Oh my gosh, don't always break your pencil lead though. And always check at the end of your test. And so don't take any time during your test checking while you're taking the test, but at the end of the test, and you should check in the original. So this is, and you should check both equation 1 and equation 2. So equation 2 is 5 times -3 plus 3 times 2/3 equals -13. Okay, so I'm going to be checking both of those. So here, I'm putting it in my calculator. You don't have to put it in your calculator. I know that I talk about the fact that if I said you couldn't use your calculator, then you would want to use your calculator. And if I say you're allowed to use your calculator, then you're like, it's human nature, right? You're like, well, I want to do it by hand. And so I'm like, great, do it however you want. So I just checked it with my calculator, hot diggity dog. I'm going to edit this because you see how it's in the same form. They were both in standard form. And so this in the next one was a 5. And so I can just kind of quickly change this up a bit. This was a 3. And -13, and so it's like great. And so now I know this is the right answer. This next one is set up to use substitution, so I'm going to just go with it, and I'm going to be plugging in right in here. So the form is 2 times x, right, minus 3y equals 21. So this is my equation 2, right? I like to write equation 1. I like to write that equation down, and I like to put a big old blank right there, and I'm going to fit in here -y plus 8. Then you're going to use your distributive property and solve it normally. So that's -2y plus 16 minus 3y equals 21. So combining like terms, -5y plus 16 equals 21. Taking away 16 from both sides of the equation, -5y equals 5, right? And I think it's 5, and I'm going to check it with my calculator just to be sure. And it is 5, and I'm going to get -1 for y. And then you would need to write this, as an ordered pair. And so we just found y is -1. We need to find out what x is. So plugging back in here is the easiest, best place to find x. X equals negative of y plus 8. Well, what was y? It was -1. Negative of a negative is a positive, 1 plus 8, so x is 9. And then check it, right? Always check at the end of your test. So we do want to check at the end of our test. Back into the original you should go. So this is equation 1. 2x is 9 minus 3 times y is -1. And I'm asking myself, is that 21? And I'm putting it in my calculator to verify. So that's 18 right there. And then plus 3. My fingernails are all from the garden. Plus 3. And I get 21. So that checked. And equation 2, I'm not going to be able to use the same trick that I used on the last one because they're not both in standard form, right? So x is 9. 9 equals negative times y, which is -1, plus 8. And of course that is 9. 9 equals 9. And so this works as well. And so yay, 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 you say. Okay. So these, and I think this is stacked on yours. I hope it is. I don't know. The font got kind of wicked and kind of crazy. You notice that this one is not in any form, but that one is in standard form. So maybe I'll make them both be in standard form with x and y on the same side of the equation. So I think I'm going to add 10x to the other side over here, plus 10x, so that this equation 1, this is equation 1, 10x plus 16y equals 40. And then, so this is equation 1. And since I got it now in standard form, I'm going to stack equation 2 right on top of it or right below it, like a Wendy's double stack, because that's how you solve them, right? And so even though this kind of got out to the side, I don't know why they weren't stacked, but that's okay. I needed to rearrange that one anyway in order to use it. And so I could not have solved it from this form, and that's not a form. You know, it's not slope-intercept form. It's not standard form. And I decided that it would be easier to put them both in standard form and then use the elimination method. But that's my choice. If you said that you would rather use substitution, you'll get the same answer. I'm going to multiply this equation by -2 so that I'll be able to drop out the x's, because that's going to be my idea. So I'm going to do nothing to this equation. And so 10x plus 16y equals 40. And then I'm going to multiply this equation by -2. And you notice that the x's drop out, making 0, and the y's drop out, making 0. So this side is 0. But that side over there is 30, right? And 0 doesn't equal 30, and so had these been the same, then there would have been infinitely many solutions, but because these are different, there is no solution. Okay, so I'm going to check this one out and see how I do on it. It looks like it's set up to use substitution, and it's got some wicked fractions in it, so I think I'll live, though. Should I still substitute? Or, yeah, I think I'm going to. And so here's equation 1. So I write it down, 2x plus 3 times y, and then I'm going to leave room, equals 4. And then I'm going to put in there what y is, right, into equation 1. So it's -2/3 x plus 4/3. And that's why they had me practicing the multiplying those together, right? So this is 2x, and I'm going to distribute, but I'm noticing that, hey, the denominator's 3, so they just cancel. So that's -2x. And then here, when I multiply them, hey, the denominator's 3, so those 3's just cancel, so that's plus 4 equals 4. So this is 0, right, when you combine like terms. So this is 4 equals 4. So even if you'd solved it a different way, that's what you would have got. This is infinitely many solutions when you have this. And so this is IMS, infinitely many solutions. If I was to graph these, they would be the same line. If I was to graph these, they would have been parallel lines. And remember what you write on that? They have fancy notation in your book. The set of x comma y such that, and then pick either one. It doesn't matter. 2x plus 3y equals 4. And then that's my solution. And that's infinite. There's infinitely many solutions here. And so there you have it. We did a lovely job on it. And so we're still working along. We're on problem 27. And it does take longer when you're telling someone how to solve every single one of them than it does just to do it. So if you're thinking, boy, this video is long, you're right. This is about my nephew Austin. He used to be a bartender at the Crystal Palace, and anyway, and he used to make a pretty good Shirley Temple. He has made a batch with 10% grenadine. That's the red sugary stuff. That was too weak. And then he made another batch with 60% grenadine. That was too strong. He is now out of ingredients and would like to mix the too weak batch with the too strong batch to create 50 liters, which is a lot of Shirley Temple, but there must be a big party going on down there at the Crystal Palace that they need 50 liters of the perfect Shirley Temple. And he says the perfect Shirley Temple is 30% grenadine. How many liters of 10% solution and 60% solution should be mixed? Set up a system of equations and solve it for full credit. So we are going to do that. It's my favorite problem. It's the mixture problems. I like to draw the beakers. That beaker was not goodly drawn. That beaker was betterly drawn. I don't know. I'm not going to go back and erase my not so good one. This is the mix. All right. You put inside, you put how much, the amount you have, and that will be in liters, in gallons, in ounces, just thinking of the problems in your book. In my case, it's in liters, and it's 50. This was unknown. This is going to be the weak solution, and this is going to be the strong solution. I just called it the weak one X. I think I'll call it W for weak, and I'll call the strong one S for strong. The weak one was 10%. The strong one was 60%. And the perfect was 30%. And the mixture was the perfect. One equation comes by the inside of the beakers. W plus S equals 50. The other equation comes from multiplying by 100 to get rid of the percent sign, right? And then multiplying the inside and the outside of the beaker together. 10W plus 60S equals 50 times 30, which is 1,500. Okay. If I had a nickel for every time a person did this part right over here, but did not multiply those together over there, or put the percent sign in over there and got a decimal or whatever have you, but didn't do it over here, I'd be rich, rich, rich. And so that's, watch yourself on that, I guess, is what I'm saying. And so there's my two equations. And remember, it said I had to have the system of equations for full credit. So there's my system of equations. Now I'm going to solve it. I'm going to multiply this equation here by -10 so that I drop out the weak. It's at -500. So I have 10W plus 60S equals 1,500. So this is 50S equals 1,000. Dividing by 50. That's going to be 2. Is that right? Was that 20? And not 2? It's not 1,000 divided by 500, Donna. It's 1,000 divided by 50. That's 20. So of the strong solution, there is 20, and they already said liters, but I'm going to put an L just so everyone knows, 20 liters. If I had 50 liters altogether, then I must have had 30, right? Because 30 plus 20 is 50. And so 30 liters of the weak solution. Okay, this is 3 equations, 3 unknowns. Hold on to your hats, right? And you start off on 3 equations, 3 unknowns. I think they're probably stacked on one another, and I don't know what unstacked them. But anyway, and I don't know what's making my thing blurry right now. I'm going to put my hand down here and see. Don't be blurry, my friend. And so this is equation 1, equation 2, equation 3. I'm thinking about eliminating X. You eliminate whichever one you want. It doesn't matter. You got to do it twice. So equation 1 and equation 2, equation 1, I'm going to do nothing, but equation 2, I'm going to multiply by -2. So equation 1, do nothing. So this is 2x minus y plus 3z equals 4. I do nothing. I know nothing. Did you guys ever see that show? It was a show, oh, I don't even remember the name of it. And that one of the characters would always say, I know nothing. Trying to multiply by -2 and say that at the same time is not good. So the x's drop out as we wanted. I get -5y. I get plus 5z equals 10. Okay, I have to eliminate x again. So I'm going to do it again. I can't use both equation 1 and 2 again, but I can use 1 and 3 or 2 and 3. My choice on that. So I'm thinking about using 2. I'm going to multiply it to eliminate there by -4. Is that going to be right? Multiply by -4. So that's going to be -4x minus 8y plus 4z equals 12. And equation 3, I'm going to do nothing. So here I'm going to have -5y, and here I'm going to have plus 6z equals 7. Okay, now I have two equations, two unknowns. This equation here, you can lovingly call it equation 4 if you like, equation 4. And I'm going to call this one equation 5. It doesn't matter if I even name them. This is 1, 2, and 3. And I'm thinking about using 4 and 5 together, and I'm thinking about eliminating y, right? Because the y's are just opposite, ready to go. So equation 4, I'm thinking about doing nothing to it. And equation 5, I'm going to multiply by -1. So here times -1, 5y. Here times -1, minus 6z. And here times -1, -7. And I've given you plenty of paper here to write on. And I definitely would anytime I have 3 equations, 3 unknowns. And you notice when the y's drop out, I'm going to get -z equals +3. And all of a sudden, I know what z is, because I can take divide by -1, and z is -3. And then I can go back to either equation 4 or 5. So I'm going to go back to equation 4, minus 5y plus 5z, z is -3, equals 10. So minus 5y minus 15 equals 10. So adding 5, 15 to both sides so that I can solve for y gives 25, and I'm about to know y, right? Now I would like to know x. And I can't, it wouldn't help me to use equation 4 or a 5. They don't have x in them because I had eliminated x out of them when I created them. So you need to go back to something that does have x in it, and equation 1, 2, and 3. Any one of those will work because they all have x in it. And in fact, this one doesn't have a coefficient, so maybe I'll choose it. It doesn't matter. No matter what you said you were going to use, I'd say, yeah, that's right. So I'm going to use equation 2. X plus 2y, but y's -5, minus z, but z's -3, equals -3. So when the dust clears and I combine like terms, right there, I get x minus 10 plus 3 equals -3. And combining like terms some more, x minus 7 equals -3. And adding 7 gives me x is 4. So my solution is 4 for x, y's -5, and z's -3. and it's an ordered triplet. And yes, you do need to write it as an ordered triplet, X, Y, Z. Then, right, I got all this room over here, and I'm on always check, and I say always check at the end of your test, so that if you don't have time, then you can forego the check if you run yourself out of time. X is 4, Y is -5, and Z is -3, and this is equation 1, and I'm asking myself, does that equal 4? And so we'll put it in and we'll see if it does. So 2 times 4 minus -5 and plus 3 times -3. That does equal 4. Great. Equation 2. So I'm plugging in 4, right? 4 for X, 4, plus 2 times Y, which is -5, minus Z, which is -3, and does that equal -3? I'm asking myself, so I'm going to edit this a little bit. So I want the coefficient for X to be 1. I don't have to have anything there. I want this to be plus 2, and I want that to be minus, so subtract right there, and that's -3. Great. So I do enjoy the edit feature here. So 4 times 4 plus 3 times -5 plus 2 times -3, and that should equal -5. So now I'm making the coefficient of X be 4. I'm making the Y be plus 3, and I'm making the Z be plus 2. And I get -5. Great. So that means that it worked. And so anyway, and so I do like to just check really quickly with my calculator. Oh my goodness. And I think that these were stacked at one time. And so we'll graph these one at a time. The first one I'm going to graph is X plus Y is less than 2. You start off by graphing the boundary. And the boundary happens at equals. So that's X plus Y equals 2. So this is the first thing that I'm going to graph, and I'm going to pick convenient points on the boundary. So that's 0, 2, and 2, 0. And I know that it should be dashed line, so I'll draw it dashed. And so I'm going to draw that here. So 0, 2, over 0, up 2, over 2, up 0, and a dashed line. Then I'm going to do a test point. So there's my dashed line going in. I might also just go ahead and put that in here. I'm not going to shade over there though. I'm going to just put my final answer over there. So dashed line, just while I'm thinking about it, because I'm going to have to put the lines over here, so I might as well put it in as I go. My test point for this test point, TP test point, would be 0, 0. Putting it in this original, 0 plus 0 is less than 2, 0 is less than 2, that's true. So that means the shading in the pencil is going to go over here. And we're going to look for where the shading intersects. I'm going to draw this one in a different color. I'm going to draw it in red. And I'm going to be drawing this one. 2x minus y is greater than 4. So I'm going to be doing the boundary, and the boundary happens at equals. So that's 2x minus y equals 4. It should be solid line, right? Solid. And I'm going to pick some convenient points. 0 and -4 go together, and y is 0 and x is 2 go together. So I'm going to plug those in over here. 1, 2, 3, 4, and 2, 0. That's kind of nice. That hit that, right? And a solid going on here. I'm going to put that on here. 1, 2, 3, 4 while I'm here drawing my lines. And it's solid. Okay. Now I'm ignoring the pencil line and I'm doing a test point, TP test point, and I'm picking 0, 0, because that didn't go through 0, 0. And so back in this original, 2 times 0 minus 0 is greater than 4. No, it's not. So that's false. So that means that 0, 0 is not the solution for the red line. It's on the other side. Okay. Okay, so we did a lovely job at that. Now we already know that just for these two, we're looking for the intersection of the solutions, and that's in this region down here. Do you guys agree with me? This is not the solution over here, not both of them, none of them, only red, both of them. That's what we're looking for, both of them. So that's why it's helpful that I did it maybe in 2 different colors. Now I'm thinking about doing the last one in this crazy blue pencil, and I'm going to have to put it up here because I'm out of room. So 3 is to graph y is greater than -5. So you graph the boundary. That's at equals 5, y equals -5. And that is a horizontal line at 5. And it is dashed. So right here, 1, 2, 3, 4, 5. And it's going to be dashed. Dashed. And you can reason the ones out that are like this. This says y is greater than -5. So the things that are greater are up this way. And remember what we're looking for. We're looking for the place where we have all of the shading, right? And I'm going to put that on here, right here, -5. Right? Okay, so we're looking for where they all are. And where they all are in that little tiny triangle, right? And so I know it's crazy, but this is just 2 of the colors. Just the blue is up here. The red and the blue are over here. But in that little triangle are all of them. And so I'm going to shade that. That's my answer right there. And so I'm going to shade that. The book has some lovely shading that they use. So inside that little triangle is my answer. They asked me to say the vertices that were formed. So I'm going to do that real quick and then go on to do the last problem and have some soup as well. So this vertice right there is 2, 0. Then this vertice right here, well, it's in the red line and it is where y is 5. So I'm going to come here to the red line. This is the red line. And I know that y is -5, not +5, excuse me. Y is -5, right? So I'm going to put that in there to find out where that's crossing right there. It looks like it's crossing right in the center at -½ is where it looks like it's crossing, but we're going to see. And so to see where that's crossing, I'm taking the red line, 2x minus y equals 4, and I'm putting in y is -5 because that's the height of that, right? So 2x minus and then -5 equals 4. So 2x plus 5 equals 4. So taking away 5, and I'm out of room there, but I got 2x equals -1, x equals -½. And that's what I said I thought it was, right? I told you guys that I thought that it looked like it was at -½ and certainly it is. So -1/2, comma, -5. Well, what about that one? Well, it looks like it is exactly crossing on the corner right there, but I could make sure that it was by putting it in right there, right, into the penciled one. Y is -5. And it looks to me like it's crossing right there at the well, let's check it out. I'm thinking maybe it should be crossing at 7. And then my line here, when I put it in there, x plus y equals 2, putting in, what did I make a mistake here? Because it doesn't look, it looks like it's crossing here at x is 6. X equals 7, right, when I add? Zero, 2, and 2, 0. But this is definitely 7, negative 5. Sorry about that, everyone. My line was sloppy enough or over enough, and it can happen. I mean, when you get a far away, and that was why I checked, right? It looked like it was crossing right there, but I can see by my equation that this is 7 and 5, and I made sure that, and negative 5, I made sure that everything, that it, you know, and it was just that when I went through the point when I drew it, I'm not going to go change that one because no one's looking at it, but I am going to change my shading in here to go out that little bit more. So I didn't have a very good, just enough, right? Okay, and that one's dotted, that one's dotted, and that one's, oop, I'm off the page. This one's dotted, this one's solid, and that one's dotted. I said all the vertices where they crossed. So I did everything. Okay, last one. An airplane flies from Mile High City to an airport 600 miles away in 2 hours with the wind and 2.5 hours against the wind. How fast is the plane and what is the speed of the wind? Set up an system of equations and solve it for full credit. And then they've kind of drawn this picture here of this airplane, you know, and it's going here from Mile High City is Denver, is where that is. So it's going from somewhere to Denver. It didn't say where. And it took 2 hours to get there and 2.5 hours to get back because of the wind going against it. And this is just like those water problems with the boat. And so the rate that this is going, and so we're going to say with the wind pushing it, with the wind, rate multiplied by time equals distance. Okay, so when it goes with the wind, its time is 2 hours. And it says it's 600 miles away, so that's the distance, right? And there's two things pushing the plane along. There's how fast the plane wants to go itself, and we're assuming that's the same for both of these. And then there's the wind, and we're assuming the wind is the same for both of these. And so what we called it when it was in the water, we called it C for the current. And so I'm going to just say S plus C. And so you could say S plus wind if you wanted. S is the speed of the airplane, and C is the current or the wind. If you wanted to call it W, you could. And then against the wind would be S minus C. And this was 2.5 hours. I'm going to put 2.5 since that's exact and 600 miles. So I get this equation when I multiply these together, 2S plus 2C equals 600. And then the other equation when I multiply those together, 2.5 S plus 2.5 C equals 600. And then I want to solve that. And so now I'm going to work on solving that. And so I was thinking, well, how will I do this with the 2.5 and the 2? And they're stacked, they're lined up like a Wendy's double stack, right? So I can use my favorite method, elimination. And so I want to get rid of the 25, 2.5, 25 is times 10, right, in my mind. And I want to get rid of the 2 there. And so what could I make them both be so that would work out? And, you know, you can multiply them together. Have you guys, you know what I mean? And if you multiply them together, they're going to both be 5. And so I'm going to multiply this one by 2.5. And then, oh, I did that again. I did that on the other one too. When I multiplied these together, I was so tired that I didn't put a minus. And so allow me to distribute that and put a minus. I'm sorry, I didn't do that. I know I did that before. The last time I did one of these problems, in fact. So when I multiply by 2.5, I'm going to get 5s, and you can use your calculator to do that. 2 times 2.5 is 5, right? And I'm going to get 5c. And then I'm multiplying by 2.5. 600 times 2.5 is 1,500. And then I'm going to multiply here by 2. And see how that's going to drop out the c's? So when I do that, I'm going to get 5s minus 5c equals 1,200. So this is going to go away. 10s equals 2,700. So dividing by 10 is the speed of the plane, which is 270 miles per hour. They didn't put that down here, but I'm going to put it right here. Speed of airplane, 270 miles per hour. Now I want to find the current, which is the wind, speed of wind. So that's what I'm going to do next, wind. And you can plug it into either one of the equations that you want. So I'm going to plug it into this equation arbitrarily. So equation 1 tells me that 2 times 270 plus 2 times c equals 600. So I'm going to multiply that together. 2 times 270 is 540. And then I'm going to take away 540 both sides. So I'm going to get 2c equals 600. Take away 540 is 60. And I think that's 30 then, right? 2 times 30. So the speed of the wind is 30 miles per hour. And I feel very happy, my friends, to have done that. And so anyway, so there's that. We did a lovely job. We went over every one of them in excruciating detail. And not really excruciating. It was fun, I thought. And only made a few boo-boos. And and hopefully got them all corrected as we went. It's a lot.